Hey, how's it going, everyone? Dignified Rainback here, doing the next segment of the development. Now, I've taken a little bit of time to figure out what I wanted to do in this section. And those who may be tuning in today may have noticed I had tried to do this video a few times. I had some hiccups along the way. And now that I've adjusted those, I'm ready to re-tackle this backpack generation. This is going to be a multi-parter, and today we're just going to focus on the first part of this. So let's jump into it, guys. Let's cue that intro. All right, and we are back. So, today I have a few ideas about what I want to do here. And as I said before, I kind of did a little bit of work preemptively getting us to this point. I'm going to turn my music a little bit. Okay. So, there was a few things in the first video that I was trying to do. It just took me a couple of hours to get the math right, because I have a hard time following my own logic sometimes. But today I'm looking forward to introducing you to this concept. So in my game, in TerraFarmers, I have come up with a kind of an interesting, or at least interesting to me, way of establishing and working with the kind of the limitations of the system, as well as a couple other things here. So let me boot this up and I'll show you. So for simplicity's sake, let's get rid of some of this. All right. So one of the things that I want in my game from the very beginning is a weight value. And this is to to simulate the carrying of something heavy. And I was thinking about that, and we have a couple of ways of doing that. But as I was beginning to work on this project, and over the last stream that I ultimately ended up deleting and we're redoing here today, I was trying to figure out a way, how do we simulate weight in a system that has an inventory grid like this? And so I thought of something called, that I kind of came up with on my own, called a procedural backpack. And for a lot of you, you're probably like, what does that even mean, sir? Well, let me tell you. Let me tell you here. It's a little bit of a wild concept, I think, but I'm excited to kind of share this idea with everyone. So rather than just having a grid for our backpack, let's say here's our inventory system, right? Inside of its little, no, that is so sloppy. Inside of its little bubble here, this is the backpack in the game. Let's say this is Minecraft or something. You've got each square is for, a number of items. We can put those numbers there. This is how many items are in each square. And we're going to kind of keep track of what is in the square and what isn't. And so, as that, we want to generate the cube one cube at a time, because it's procedural, right? We want to generate these cubes in an array, and an array is an infinite line, more or less, that starts with 0 and goes to whatever value our end value is. And because we start at 0, we always need a -1 to make sure at the end, to make sure that we, because we're counting from 0 to 1 to 2 to 3 to 4 to 5 to 6, 7, all the way up to wherever we're going. And because 0 starts as a number, we need a -1 to make sure that we account for that, or set this to start at 1 and count from 1. So but basically we're going to store an inventory item that has an ID in it, something that we can keep track of, like what inventory number this is. That way we can have persistence between, let's say, this and let's say in our game we have the boxes at the bottom, kind of like Minecraft, where we have, this is number 1, this is number 2, 3, 4, 5. These are our inventory slots that we can access with our keyboard. WASD 123. And so storing an ID allows us to not only make sure that this number 1 and this number 1 are the same, but also it allows us to do a system where we can keep track of what is in each square and save that to a data system or on the server, letting us know so that players can't dupe their inventories. So, yeah, so what I'm thinking is we're going to generate this 1 cube at a time, and we're going to allow the player's inventory to generate on an x-axis, and then once it reaches a certain number, which is in this case we're going to do 5, we want to start a new row and start it all over again until we reach the total number. And we want the backpack to stop at the player's max inventory. That is okay. So yes, sorry about my chicken script here, but we want to get it to our player's max inventory size. So that's the concept of how we're going to figure out the basics of our backpack. But one of the things I wanted to do in my system is edit and remove the squares based on the weight of the inventory. So if a player, to simulate carrying something heavy in our game, what I want to do is reduce the number of squares that we have. Let's say there's something really heavy in here. Let's say it's, even though it only takes up 1 square of our inventory slot for the item, we want to limit from the max that our player has the number of squares that are being generated at that time. And this is where we get that procedural. It draws it in real time. It does modifications in real time. So it's a little bit more taxing on the client side, but I think this loop logic is a sound way of doing this. So, all right, let's jump into the coding here. Let's start with this. And all right, I gotta pull up my notes. Like I said before, I had gone through and worked to make this a bit more prepared for us. So, I'm gonna start with the initialize step. So we're gonna make a couple groups here. So we're gonna do, the first group is debug. The second group is going to be initialization. And then we're gonna have a draw script inside the initialization, and this is to draw the inventory. And we'll do draw the inventory grid. And so in our initialization, where we start our script, we want to begin with some basics. To start this off, we want to create a script that is at the beginning. So every time a script begins, we're going to run these variables. We want to change the player variable, and we're going to create this one. We're going to call it inventory slots. So we need a variable. It's a number variable, inventory slots. Let's say we're going to set it to 12 for this test. We need, as I was saying before, we're going to generate on a grid. So we need to know what is the X count. So how many do we count in this direction? We also need to know the Y count. And then we also need to know each position, because this is an X1 so not only are we trying to get the X and Y of our grid, we also need to get the position of each cube, which would be in, like, let's say X1, Y1, because we're on the Y, this is Y1, this whole section, and X1, X2, X3, X4, X5, and then reset that to Y2, so X1, Y2, X2, Y2, X3, Y2, and all of that. So, we're going to just copy this and paste it, and now we actually want this to be a scene variable, so I guess it didn't really matter what we did there. The scene variable, we're going to set it to X count, and we're making this up on the fly, so oh, oops, we're going to set the X count. I'm just waking up, so I'm a little slow, a little disoriented today. We're going to set the maximum to 5. And we're going to do the same thing with the Y count. Oh, lowercase, Y count. We're going to set that to 5 as well. So our max grid right now, that we want it to loop to, is, and on the Y count, we actually want to do, let's see. This is a little bit of math here, but I think we always want the Y count to potentially grow 1 length longer than the actual inventory. So to do that, we could do, let's do this in brackets. So player dot inventory slots. Oh, this is player variable, actually. Inventory slots divided by, in this case, the X count, because that happens to be 5. The variable of X count. So this is the reason why we're dividing it by 5 is because we want it to be consistent with the X, and we're gonna divide it by 5, right? And then we're gonna plus 1 because we want to add an extra layer in the Y in this. So even if, let's say we have 10 on total inventory squares, that's 2 rows of 5. Because that's two Y's coordinates. So we have Y1 up here, and we have Y2 down here. Let me clean this up a little bit so we can see a little bit better here. Let me get rid of this. And so, yeah, so basically, right, we have, this is, oh my goodness, all right. Got it. This is Y1 and then Y2. And so for this, if we had 2 rows, it would be a total of 10 cubes or 10 inventory. But now we want our system to always assume that we can go down 1 more layer. And so we're going to add the Y3 even though there's nothing there. Now, normally when we generate the grid, that'll mean that there will be always like this because of how we're doing it. We're saying, if there are, for every set of 5, add a new layer to render, potentially. And if we're at 5, prep the next layer. And so we're going to divide that by that. And then we need to create our next set of code here. So we have one more thing to initialize. We're going to do another initialization script, and this one is a OR statement. So if any of these situations are true, and we want at the beginning of the scene, we want to do this. At scene at the beginning of the scene. There we go. At the beginning of the scene, we want to do this, as well as whenever a cube or anything is created. So for now, we're going to trigger this once while true. And we're going to add some keys here. So if the keyboard, this is only for demo purposes, but this will be fine. So whenever the keyboard page up is pressed, or if the keyboard button page down, this isn't great logic, but this will, at least for this part of our setup, this should work. So let's see here. We want to, at the beginning of our scene, we want a new variable. Let's see, we're going to say player. We want a new player variable. We'll say a number variable, and we're going to call this inventory count. So if the inventory count of the player, we're going to set it to 1. We'll set it to 0. Then we want the scene variable. These should also be player variables, now that I'm thinking about it. Player... Well, actually, we'll leave it as a scene variable for now because we don't want the player to be able to mess with it, but this is a global level, so we're going to need to figure that out. I think I could do for each instance of player, change these variables. But for now, that'll be good. We want to change the scene variable of position X. So this is where we were talking about before, where we now have our position of the actual cube. So this one, even though this is Y1, this is X1. Right? And so X1, X2, X3. And so we could say Y1 or X1, Y1, X2, Y1, and so on, as we previously discussed. Let's go back here. So we want to set this position to 1. And we want to set the Y position Y. And I'm doing lower cases because that's necessary in this particular case. We don't want to use capital X's. We don't want the system to get confused. Capital X's are part of the built-in language scripts, so we don't want to mess with that. And we want to create a new Boolean value for inventory looping. Because we're going to be running a loop to generate. And like I said, this isn't great. This is going to queue every time one of these things happens, and we want to modify that later, how we initialize it. But to get the concept across, this is how we're going to do it. So the next thing we're going to do is go back to a scene. We're going to go to a scene Boolean. And we're going to say inventory looping is equal to true. So now we have the basics, right? So now we're saying we have an inventory count, which is the total number of squares that are currently visible, the total maximum of squares that we can have, and then their position. This is where we start drawing the inventory grid system, and we add that right under in the hierarchy. We need to put that in our loop. And so we need to add in a while here. So while these conditions are true, let's do this. So if the looping of our scene is the first thing we need to do, so if the loop, and this is a Boolean, bool. So if the scene Boolean for inventory looping is true, and we want to, this is a really important thing we need to do, if the scene variable, or in this case, if the player's variable, number, if the number variable of the inventory count is greater than, or is less than or equal to, rather, the value of, let's see, player variable, inventory slots. There we go. So at any point, so stop this, like both of these conditions have to be true. And if the inventory count of the player is less than or equal to inventory slots, continue to generate the grid. But as soon as our player reaches that point, we're going to turn down our music a little bit. For me, it's a little loud. For you guys, you probably barely even hear it now that I'm thinking about it. There you go. So, under these conditions, we want to do something. So that we want to repeat something. And in this case, we want to start with generating our position. So in our game scene, I've created I've duplicated our origin similarly to the origin that we're using for developing our map, generating the biome structure. We're generating another origin, an inventory origin. So we're going to need to spawn. We need to create an object. So create an object. We want to create a inventory slot, which is our UI element, at the position of inventory origin dot x, and this is why, again, we don't want to use a capital X, plus 32, because we're using a 32 by 32 grid, and we need to multiply that by the position, because so we're saying that we're going to add 32 in each direction, because we're going to do the same thing for our Y. And we need to take a variable position. We can go variable. And we want to do the the position X. And so this math is pretty straightforward, but in case you don't understand what's going on, we don't want that cat. Let's talk about this. So we want to generate that on the UI layer. So every time we create a inventory position, let's say up here we have our inventory origin cube. We're saying, because we have 32, this is a 32 by 32 object, length and width, right? We're saying we want to add 32 by 32 when we first spawn this, so it's going to spawn here. And then from that position, we want to make sure that we're multiplying by the number of POS, and then on the X and Y, but it's based on, right now it's 1 and 1, so it'll only continue to produce here. And right now it's going to only produce in the first square because we're only multiplying it by the default value. So we need to start changing those values as incrementally as we start developing our grid, drawing our grid. So that brings us to our first thing. So the first thing we need to create is we need to add something to a variable. And the cube count, we're going to take another player count. We're going to say for the inventory count of the player, we're going to add 1. So every time we create an inventory, add a counter. So eventually this will become over what that value is. Oh, I hiccuped. And we're going to take the X position, and every time we create one, we're going to add 1. Right? Until we hit that 5th number. And so we need to add now the logic of, we have an X count, but we're not testing the position to the X count. So we need to create a sub category for this, and we need to move on to the next step of what we're doing here. And it's pretty straightforward. Like, we're almost already done with the basics of what I wanted here. So now, we need to do a quick check. So we're going to say, in this case, if the scene variable, so we're going to go if the scene number variable of position X is greater than the variable X count, and this is a scene variable of X count. Oops, I did that. It told myself I was going to do that, and did it anyway. So if the X position X is greater than the X count, and in this case, actually, we want to go greater than or equal to, just to make it, because at 5 we want to. Actually, no, it needs to be greater than. If we do greater than or equal to, at 5 it'll always break to a new line. And I'm wondering if it'll do that to the 5th line, so it'll only be 4 wide. We don't want to do that. So we then want to set the X position back to 1. And we want to add a Y position. because this is like imagine a typewriter. As we type to the end of this, we need to return back to the next line and start the count over again. So we got to go back to the first X position because that's X1 going this way. So X position, or X, Y. So now, come on. And we're going to set it, or add one, rather. And then, and so we can add a little comment here. Just, it's a good idea to make sure that you understand in your own code what's going on and make it so that other people can read your code. So I think that while looping is true, or this is at end of row, return to X1, move down 1 Y axis. And then underneath this, we need one more condition. And if the variable of position X is greater than if the scene variable of position X is greater than the variable of X of position X, set the Boolean. Oh, this we don't. Well, hold on. That's wrong. We don't want that. We want scene Booleans, and we want to set this to false. And then we want to go back to our debug, and we want to start adding our first debug section here. And this is pretty straightforward. We're going to say at the very beginning, if we're in the preview editor of our system, so preview. So if our game is running the preview, what are we going to do? We have two functions that we want to do. If the keyboard button of page up is pressed, and if page down is pressed, and we also want to trigger these once. We want it to infinitely go, and we're going to do that to both of them. And then we want to trigger the loop. I believe. Give me just a second here, and I'll run this through my head. Oh, no, we don't want to do that. We want to instead, into our player inventory, we want to add 1. And then if we go down, we want to subtract 1. And then not only do we want to do that, but we also want to delete the inventory slot. And then we want to change the inventory ID. And we'll add that here in a minute. So for now, let's see if this worked. So now, there we go. We can already see page up and page down is working. So now, basically, if we only have 5 slots, it'll go across to the 5. And then if we wanted to, let's say we expand our inventory dynamically through power-ups or other things in our game, our inventory size will increase. And let's say we'll go back to 12, which is our default. Let's say we have 12 inventory slots, and we carry something heavy in that heavy object. So rather than in RPGs, let's go backwards here and rediscuss the fundamentals of this setup. So in some RPGs, and I'll drop the name Diablo, for example. So anybody who's familiar with that will understand this concept, I think. Let's just add a couple of these in to make this a visual example. Again, I'm a visual person. This is just how my brain operates. So what we want to do here is let's see, show off the kind of the Diablo format. So if we had let's say a dagger or something in Diablo, both of these squares would end up being taken up by, let's say, the dagger, right? So this is an item in use. We're gonna cut this out and add it to a new layer so I don't have to keep doing that. Go back to our first layer and hide that. Okay, so our items, let's say, take up 2 slots in Diablo. And that's a one way of representing. Let's say that this is, get the white again. Let's say that this is a dagger or a knife, whatever. And so our knife is, let's say it's taking up this inventory space. So we could do a system like this, but that doesn't really represent very well. You know, I mean, this is one visual way of showing that items are weighted differently. In our system, instead, like I said before, we want to reduce the number of squares that are visible. And so in our system now, if we're carrying a heavy object, it will reduce the total number of squares. So in this case, we're saying, hey, listen, if the inventory size is, let's say, a maximum of 15, and we carry a heavy object, reduce it maybe by 3. And so our carrying capacity, if we have a heavy object in our system, so moving backwards here, we can get rid of this. We're saying if we have, let's call this heavy, so let's color it red. If we have a heavy object, then what we need to do is nix these squares. And we'll just do a black around this. Actually, let's do a red square. Right? So if we're carrying a heavy object, reduce the inventory by 3 squares. And this is how we are going to simulate weight, carrying weight in our system. And this is to emulate things like in Astroneers when you are carrying something that's heavy. And that's a game I keep talking about. And if you haven't seen it or played it, you should play Astroneers because it's amazing. But in the game, you carry, let's see if I can actually open this. In the game, you carry heavy objects to go research them. And we want to carry something similar in our game. And so the only way I could really think about representing that is to do this system. So here's this is it. We have a procedural generated inventory that is more or less depending on some attribute changes. In the next video that I want to do here, I want to start assigning each of these their own ID and start building the inventory system. So for now, we just have a generating grid that doesn't do much, but we do have a way for us to visually see those changes in real time in our inventory. Now, because of the way I'm running our code, every time this is being generated, we're multiplying, we're going to end up changing the ID. And right now, because of the way that this system is set up right here, when we do this, it's redrawing the inventory squares that are already there, or at least rerunning the script on them. So if right now I said change this variable, let's say we start at 1, 2, 3, 4, 5, then it'll remath it, and this will be 10. This one will be 5 and 10 because we need to store this information, and we'll do that in the next video. So I just wanted to stream a little bit this morning to show you guys what I had been trying to do previously. This is a much shorter stream than my multiple hour ones. If you found this valuable, let me know in the comment section, and we can talk more about how to develop your inventory systems. I know that this is a pretty hot topic across. This is one of the harder things that you can do in coding. There's a lot of array work. This is a very advanced sort of feature, and with our dynamic system, it's even more robust. And so we need to make sure that this is polished and optimized. And I'd like to do a little bit more research to make sure that while I'm teaching this, I'm not just humming and awing as I'm struggling to figure it out. I think this is really important information. And if you wanted to visually show all of your work, we can then go to your inventory slot. And here, we can actually change this variable, let's say to 5. And rather than multiplying, and it'll always, if we get rid of this player variable, and actually we can keep, now I'm thinking about it, we can keep this and just remove this. And now it'll always generate, oh, oops, we don't have an ending point. And we can say now, actually, and this is where this comes into play. This is broken. That's funny. We want to actually add this to be inventory slots. So if the position X is greater than inventory slots, there. So now we have this. And actually want to say if this is greater than cube count. We could say this is kind of, I mean, it's working, but it's not working the way that I would want it to. That's infinitely generating because our position, because we're moving down, our X position will never equal our... Wait. Let me go to my... I'm missing something here. We're using the same concept that in our not our planting inventory. Come on, world generation. World generation. If X, oh, we need this needs to be Y. And because we're not generating a full grid, we can just do this. Or set this to a 5 by 5. There you go. So 5, 10, 15, 20, 25. Now, our player inventory isn't really being taken into consideration here. But if you just wanted a grid inventory system, and you could then very easily, because they're static now, right? Whenever things become dynamic, we have to take more variables into consideration. But because we're not, we just have a 5 by 5 grid. So for those that are interested in just generating a grid, this is how you would do that. You would need the more complicated variable states that I have running. And hopefully that works for you. So we're going to add back the looping element that we had going on here. There we go. And we're going to set this back to position Y. And we'll run this again. And see, so we can then see that this is functioning. Sorry about my Discord pings, guys. All right. So, yeah, that's me signing off. Hopefully that you guys, this is how we're going to do inventory in TerraFarmers. Hopefully this, again, you find this valuable. And thank you guys so much for stopping in. I had a great time on this session. And I'm hoping that that this can be useful to you. So thank you guys so much. And I'll catch you soon. Ciao. Cue the outro. Let's go.